So Brown, Anderson, and DePry, Chapter 11, then goes into a quick overview of visual analysis, so interpreting your data. Again, this is a review of Gaston Ledford, but it's a really nice summary of how to interpret your data. They give a table on page 216, chart 11.7 of different visual representations of graphs that have a really nice illustration of all of these points. So please refer to that as you go through this lecture material. So they first break it down into the same two areas that Gaston Ledford did, so formative versus summative data analysis. So formative, again, is just within phases, whereas summative is across phases. The goal with formative is in order to guide your studies as you're going and to predict future responding throughout your study. The goal of summative is to basically just prove that's a functional relationship and the efficacy of the intervention. So within formative, you want to look at the number of data points, the level, the trend, and the variability. And that is, again, just within that phase. So within a phase, you want to ensure at least 3 to 5 data points in order to establish stability. You may need to prolong that if there is high variability or that there isn't a steady level or trend occurring within that phase. So 3 to 5 is a good place to start. However, due to those issues just mentioned, you may need to prolong it. Additionally, if there are safety concerns, you may want to shorten it as well. But 3 to 5 data points is a good estimate for the number of points needed to analyze within a phase. You then look at the level, which is just the average performance across data points, and then the trend, direction, and slope of the data path, and then variability. Your goal is low variability within your phases. You want to see pretty stable data. So within summative, which is across phases, you also look at level, trend, but then you add in overlap and latency. So level across phases is slightly different. What you want to analyze is the changes in level once conditions are introduced. So the larger change across an adjacent condition, the more powerful the intervention. So if you start at like a lower level and then intervention takes place, level increases, that signifies and supports possibly a functional relationship. The trend is also along the same lines. So within, across phases and adjacent conditions specifically, you want to see visible changes in the level and trend, and that will both suggest an effective intervention. Overlap basically just means that across adjacent conditions, data points shouldn't necessarily overlap, so you shouldn't have the same data points in different phases that are adjacent. So the fewer the overlaps, the more powerful the effect also. And then latency just means that there is an immediacy of change. So the immediacy, once in a condition is implemented, supports causation, so that functional relationship. So all of those areas, level, trend, overlap, and latency, work together in order to support that functional relationship. And then again, remember Horton's definition that there has to be at least 3 different points in time or across 3 different conditions to that needs to be replicated to support that functional relationship. So a study that's just an A-B design won't necessarily support a functional relationship. You might see across conditions, the level change, the trend, the overlap, latency, all of that great stuff. But in order for it to be a functional relationship, we need to have at least 3 different conditions. Again, just a review of Gaston Ledford, but I think it does break it down very nicely and succinctly. And then that graph again on page 216 really helps put the visual to the information.